Imagine taking a shortcut through space and time, a wormhole, a mysterious portal that might just connect two distant points in the universe in the blink of an eye. Could these science fiction gateways actually be real? Today we'll explore the fascinating theory of wormholes, how they're connected to Einstein's equations, and whether they could one day make faster-than-light travel possible. To understand wormholes, we need to look at Einstein's theory of general relativity. According to Einstein, massive objects like planets and stars warp the very fabric of space and time, creating what we call gravity. Now imagine bending space-time so much that two distant points touch each other. This, in theory, creates a wormhole, also known as an Einstein-Rosen bridge. General relativity describes gravity not as a force, but as the bending of space-time. Picture space-time like a giant rubber sheet. Place a heavy object, say a bowling ball, on that sheet and it creates a dip. Smaller objects, like marbles, roll toward it, just as planets are pulled by gravity. Now imagine if that rubber sheet folded over and touched another point. This is essentially the concept behind a wormhole connecting two seemingly far-off regions of the universe. If wormholes exist, they could, in theory, allow us to travel vast distances instantly. Think of the universe as a piece of paper. If you wanted to travel from one end to the other, you'd normally have to move across the entire length. But if you fold that paper so the ends touch, you've created a shortcut, a wormhole. Enter one side and you could emerge on the other, bypassing the distance in between. However, wormholes present several major challenges. First, they are inherently unstable. A wormhole, if it were to form, would likely collapse in an instant, far too quickly for anything, let alone a spaceship, to pass through. Theoretical physicists propose that something called exotic matter, an unusual form of matter with negative energy, could be used to keep the wormhole open. But exotic matter itself is highly speculative and has never been observed in sufficient quantities. So are wormholes real? The truth is, we don't know. We haven't observed a wormhole directly, and they remain a mathematical possibility rather than an experimental reality. Some scientists believe that wormholes could form naturally in the chaotic environments of black holes or during the early moments of the Big Bang, but so far, they are purely theoretical. Quantum mechanics, the science of the very small, also enters the conversation. There's an idea that tiny subatomic wormholes might exist all around us, appearing and disappearing at incredibly small scales. These so-called quantum wormholes could potentially help us understand how gravity works on a quantum level, and even provide insights into unifying quantum mechanics with general relativity, one of the biggest mysteries in physics today. One of the most exciting aspects of wormholes is their potential for faster-than-light travel. Imagine being able to travel to a distant star system not in thousands of years, but in mere moments. Theoretically, if you could stabilize a wormhole, you could create a cosmic shortcut. But there's a catch. Einstein's equations suggest that nothing can travel faster than light in normal space-time, so using wormholes might be our only loophole. And even then, the energy requirements and unknown dangers make this a distant dream. If we could enter a wormhole, what would it be like? Visualizations often show a swirling tunnel of light and energy, but in reality, we have no idea. The intense gravitational forces and potential tidal effects could rip apart anything that enters. Even if exotic matter could keep the wormhole stable, navigating it would require technology far beyond anything we currently have. Despite these challenges, the concept of wormholes remains a tantalizing possibility. Researchers are constantly exploring the boundaries of physics, using experiments like those at CERN and the Event Horizon Telescope to push our understanding of the universe. Could we one day discover a naturally occurring wormhole, or perhaps create one artificially? It's impossible to say, but the journey to find out could lead to revolutionary discoveries about space, time, and our place in the cosmos. Wormholes capture our imagination because they represent the ultimate escape from the limits of space and time. They remind us of how much we still don't know about the universe and how much there is left to discover. Whether they turn out to be real or not, the pursuit of understanding wormholes pushes the boundaries of science and challenges us to think beyond the limits of our everyday reality. If you enjoyed this journey into the unknown, make sure to like this video and subscribe for more mind-bending explorations of science and the universe. Who knows, maybe one day we'll step through a wormhole together.